Okay, now we're going to talk a little bit more about measurements. The first thing we need to do when we talk about measurement is talk about how we write the measurement of a segment, right? So if we draw something like this, if we write something like this, that is referring to a line segment, the shape, a line segment. If we want to refer to the measurement of that segment, what we do is we go like that. We just write AB without a line over it. So this guy's a segment, and this guy is a measurement. Okay, for segments we use congruence. For measurements we can use equality, because remember, a measurement is just a number, right? So let's run through some of these properties of equality, but let's talk about in segment land. Okay, so let's just say, for the sake of argument, that I know that AB is equal to 7. Okay. So what I could say here is something like this. I could say, if 7 equals AB and AB equals BC, what's the next statement? Well, then 7 equals BC as well, right? So that's kind of an idea of the transitive property of equality, right? This is equality. This is saying a segment measurement is a certain amount. This is saying congruence. This is actually saying there's a number attached to it. So notice that these guys have lines over the top. These guys don't. Here I'm using congruence, and here I'm using equality. But otherwise, it looks very similar. Okay, so that's kind of a transitive property. Okay. Reflexive property isn't too much different in equality land either. Any segment measurement is going to be equal to itself. So you could say that the measurement of AB is equal to the measurement of AB. Right? We're not saying that the segments are congruent, we're saying their measurements are equal, which is a similar statement, but not exactly. So this is reflexive. Okay. And then symmetric is you can kind of switch. So we'll do it with a number here with symmetric. So let me switch colors again so we don't get confused. Okay, so I could say that like AB is equal to 7, right? The measurement of segment AB is 7. That's the same thing as saying 7 equals AB, right? I can swap the order in equality, like it doesn't really matter. So that's not like too enlightening because it looks very similar to what we have. You're like, okay, well that's not any different. I just change it from a congruence to an equal sign and don't put a line over it. Okay, what's the big deal? The big deal is that there's more that we can do on this side. Because remember, there are more properties of equality than there are properties of congruence. So let's kind of go back and see what we can do over here on the equal side, but that we can't do on the congruence side. Okay, so let's get rid of this. All right, let's start with just something simple, addition property of equality. Okay, so if I had AB is congruent to BC, right? And then over here, sorry, make these segments, and over here I have AB equals BC. Okay, let's say I wanted to add a number to both sides of this equation, right? What I could do is I could do something like this. I could say plus 5, right? So maybe I add some segment somewhere, I add another segment off to the side, it's 5 long and I want to do that. I can do that here. I'm allowed to do that. This is an equation, right? This is some measurement equals some measurement, and I'm adding the same thing on both sides. I'm not allowed to do that here. I can't do plus 5, because this is not an equal sign, right? This is a congruent sign. This means two shapes are similar, or they're the same as each other, right? To say, hey, these two shapes are congruent, plus 5, they're still congruent, that doesn't make sense. It doesn't make sense to say segment plus 5 is congruent to segment plus 5. Okay, so we can't do that here. We have to do that in equality land. We have to kind of shift over here. Now the way that we get from here to here is basically to just use the definition of equality. If you know two things are congruent, you can say, okay, these two things are congruent, therefore their measures are equal, and then you can add 5 to it. So our bridge over from congruence to equality is the definition of congruent segments in this case. which we're going to use later. So the same is true for multiplication and division. I can't multiply both sides by the same number in congruence. 5 times segment equals 5 times segment doesn't make sense, or is congruent to 5 times segment doesn't make sense. But if we're talking about measurements, we can do that. So we can only use properties of equality, multiplication, division, addition, subtraction, if we have an equal statement with measurements, not with a congruent statement. So these are actually all going to be kind of similar idea. All right, let's look at substitution, because that's kind of an interesting one. So what I can do here on this side is I can do something like this. AB plus BC is equal to AC. Okay, if you recall, that's called the segment addition postulate. I'm just saying that this segment and this segment get together, make the measurement of this segment and the measurement of this segment make this segment together. That's called, again, the segment addition postulate. If I had another statement that said AB is equal to 7, right? What I could do is I can replace 7 with AB and vice versa. Remember, the substitution property of equality says if two things are equal to each other, then I can replace one with the other. And so what I can do is I can rewrite this as 7 plus BC equals AC. I can't really do that over here because, again, we're not talking about numbers. There's not a substitution property with congruence. I can't say because two things are congruent to the same thing, they're congruent to each other. You can kind of do that, but it has to be transitive, because remember, transitive and substitution are a little bit different. Let me give you an example of what I mean. If I said AB is congruent to BC, and I also had CD is congruent to BC, I can't say that AB is congruent to CD. I know that's kind of weird. We expected, like, well, they're both congruent to the same thing, right? But in transitive property, this would have to go AB to BC and then BC to CD. So although this is kind of true, we have to use a symmetric property first before we can use the transitive property. So I can't necessarily just replace this guy with this guy because they're both congruent to this. I know that's kind of weird, but there's not a substitution property of congruence. There is a substitution property with equality, though. Okay, so right now that's a little abstract. You might be going, oh, okay, cool, so I have properties of equality, properties of congruence. What we really need to do is we need to get down to a proof. We actually need to start using these things in a proof so that you can really see where you need to use properties of equality and where you need to use properties of congruence. So in the next video, we're actually going to set up a segment addition proof, and we're going to use some of these ideas to be able to reason through that.